Interstellar propulsion possibilities. Interstellar spaceflight has two things going against it. One, lack of speed, and two, fuel to get to the star of our destination, at least for Earthlings. Take last weekend, for example. A couple of friends of mine, Magloob Gloob and Xantar, were talking with me about going on a field trip. To make a long story short, they want me to join the Interstellar Canoe Club with them, a popular recreation club among the spacemen of our galaxy. Next month, the club is meeting on the planet Vulcan in the Epsilon Eridani system, 10 light years from Earth. There's a whitewater river that's the talk of the stellar neighborhood. But how on earth to get there in 30 days? From what I've heard, the other members of the club have their own hyperspeed transportation, so getting there is no problem for them. I don't want to ask for a ride because they'll think that Earthlings are backward for not having the latest hyperdrive. It's embarrassing, so now I only have 1 month to figure something out. I was reading in Popular Mechanics, or maybe Cosmopolitan, that it would take about 10 to the 34th watts of energy per second to bore a 4-inch diameter tunnel through space-time. In other words, create a wormhole shortcut. The entire sun only generates 4 times 10 to the 26 watts per second, so that's out. Besides, a 4-inch hole would not fit my canoe. To form a portal big enough to paddle my canoe through would take the power of a quasar, which is about 10 to the 39th watts per second. The trouble there is that I would need faster than light travel just to get to the quasar. These clubs can be a pain in an Alpha Centaurian's 3 asses. I mean, 3 of something. Never mind. Now, what's an interstellar outdoorsman to do? I remember hearing about a faster-than-light idea brought up by an obscure German scientist. His name was Burkhard Heim. At first, I thought it was a theory by Manhard Heim, the notorious ladies' man, but then I remembered that those two were twin brothers. One was endowed from the neck up, and the other from the waist down. Anyway, Burkhard thought that electromagnetism and gravity were two sides of the same coin, and that their energy-induced transformations were the key to faster-than-light travel. His idea was simple. Place a heavy superconducting coil of wire on a flat, even plane and situate a fast-spinning, rotating ring above it. Send immense amounts of electricity through the coil and the ring will begin to levitate. The ring will hover because the space between the coil and the ring will begin to convert photons and theoretical gravitons into hybrid gravitophotons. These alleged gravitophotons are the source of antigravity. How much electricity the coil needs is anyone's guess because Heim was vague about many relevant details. For reference, an MRI machine that produces 1.5 Tesla uses a 480 volt source. In the late 1990s, Andrew Geim, not Heim, and Michael Berry levitated a frog with 16 Tesla. The fluidity of the water inside the frog greatly aided the frog's conversion into an electromagnet. It would be a different story to try to lift a solid rock into the air. Heim claimed that if you really turned the juice up, so many gravitophotons would be produced that the rotating ring would enter another dimension where the speed of light is greater than 186,000 miles per second. This way I could get to Vulcan in 75 days, provided that a mobile Heim canoe contraption could be built. Not good enough. Now, a pulsed nuclear fusion canoe is tempting, but it would never reach light speed, much less exceed it. Still, fusion would be a big source of earthly power, and it's a shame that humans can't make better use of it. The reaction is simple to understand. Take 4 hydrogen atoms and fuse them together to create a helium atom. The new helium atom does not need all that extra strong force that it received from the 4 hydrogen atoms, so it would release the excess energy in the form of photons. Photons can also be called gamma rays. Call them anything you want, but just know that it's an awfully large amount of energy. Maybe the idea of the Casimir effect could work because of its directness. The premise is that empty space is not empty at all, which is no news. It is full of energy and forces and virtual particles that give it what is known as vacuum pressure. So let's say that something could clear a path of all these energies and pressures from Earth to Vulcan. Then I sat in my canoe and allowed the vacuum pressure to rush in from behind. The effect is that the incoming force would push me right to Vulcan at close to light speed. Then again, it would still take about 10 years to get there, so no good. I just don't know how fictional hyperspeed warp engine canoes did it. Space-time is not something that can be ripped or blown through at the drop of a hat. If that were the case, we would all be living in a Swiss cheese universe with no continuity. Every time a star emerged or exploded, the sudden burst of energy would have blown a hole into space-time. There probably wouldn't even be a universe to speak of. Maybe the warp engines just created a bubble in space-time for the canoe to ride in. That's a laugh. The energy needed to maintain that bubble would probably exceed imagination. Just the same, no one is developing quasar power anytime soon. But maybe, just maybe, I can get to the canoe outing another way. I'll not just warp space with no rips, I'll fold space. I remember watching the third stage Guild Navigators of Dune doing it. That was a pretty good movie, so it's worth a try. So let's see. Under all the matter and energy in the universe, there's space-time. It's like saying that space is a huge pool basin, length, width, depth. The distilled water filling that basement is analogous to time, flowing and in motion. All the minerals and particles added to the water would be like the matter and energy permeating space-time. If I could attract or grab the space-time that's around the Epsilon Eridani system and pull it over to Earth, then I would not have to move a muscle and still be at Vulcan, traveling without moving. I'd still have to make sure I don't pull Alpha Centauri space into me. The navigators were able to fold space with the use of Holtzman engines. Maybe this was Grandpa's engine. The engines, programmed by superhuman navigator minds, reached out to a destination point and pulled it over to them. I was never a big fan of mental enhancement stories because I consider them easy fixes. Deus ex machina, I think that's the term. However, I think the author Frank Herbert was onto something. It's very possible that the future of space travel will lie in super-evolved human brains, either by genetic manipulation or by nanorobotic implants. For now, though, this idea gets shelved. Antimatter. Again, it still can't exceed light speed, but it doesn't hurt to talk about it. Antiproton annihilation is on every amateur scientist's lips these days. It's the reaction that propels the Area 51 alien spaceships, according to Bob Lazar. However, it's not as efficient as Bob would have us believe. The explosions do create enormous amounts of energy, but a lot of that energy remains unreleased in discharged pions. Overall, Bob's alien technology is silliness to the 9th degree. Anyway, positron annihilation is the much better choice. Positrons and electrons are fundamental particles that approach the subatomic depths of simplicity. Therefore, their stored energy is released as photons, without the residual particles given off by protons and antiprotons. As it stands, though, antimatter costs about $100 trillion a gram, and I still need money to buy hot dogs for the cookout. There's one more possibility, but it's a long shot and it's complicated. It has to do with cosmological inflation. For those who don't know, inflation is the idea that space-time once exceeded the speed of light. I guess that if it did it once, I can get it to do it again, and then I'll ride the speed wave to Vulcan. Now let's see. In the beginning, everything in the universe was compressed into a volume of about 2/3 of a liter. That includes all matter, energy, and space-time. How did I figure this volume? Well, the greatest density that can be achieved is Planck density, which is 10 to the 93rd kilograms per liter. The universe is estimated to have a mass of about 10 to the 60th kilograms. Therefore, the universe would fill about 2/3 of a liter at Planck density. Then bam, the biggest explosion, or should I say expansion, of everything ever. As soon as that happened, the universe ended up with two kinds of energies, positive and negative. Matter and everything else have positive energy, while gravity has negative energy. Since they are of equal strengths, the entire universe has an overall energy value of 0. Here's the puzzle. The Big Bang explosion of positive energy should have been neutralized by gravity's negative energy, and the flying nuclear shrapnel should have reversed course and been snuffed back to 2/3 of a liter. But that didn't happen. Let's just stop a moment and think about what caused this primordial expansion. But why the compressed volume of mass to begin with? Let's just call it a ball to make things simple. So what was with this compressed ball of universe? Well, I guess that if there was space inside the ball, then it would have meant that positive energy had an advantage. Did it? It would explain the current expansion. Anyway, back to our original Big Bang discussion. Positive energy kept expanding, and it was able to do this because from 10 to the negative 43rd seconds to 10 to the negative 32 seconds, the inflation of the universe was faster than the speed of light. Space-time pulled ahead of gravity before gravity could yank it back. Then, at around 10 to the negative 32 seconds, gravity caught up to space-time and slowed it to the speed of light. One explanation for the faster-than-light expansion is that the Higgs particle did not exist until 10 to the negative 32 seconds. The Higgs particle is what gives mass to matter, so space could really zoom without gravity slowing matter to sublight speed. Once the Higgs particle formed, gravity slowed things to current conditions. What's puzzling to me is the speed of space-time. If space-time is nothingness, then why would it have a speed limit at all? Why would gravity be able to slow it down? Is matter intrinsically ingrained in space-time? In the absence of matter and energy, does time exist? Cosmological inflation was first proposed in 1917 by Willem de Sitter. Since then, it has been seriously considered by several other physicists, right up to the present. Yet, there are things that do not make sense. The special theory of relativity implies that a faster-than-light object cannot slow down to the speed of light, just as a sublight object cannot achieve light speed. It may be that space-time is a form of positive energy, even without matter, which would explain why gravity was able to interact with it and slow it down. But then again, how did space-time slow down to achieve light speed? My thoughts go back to ingrained matter. Until we learn more, space-time stands as the eternal mystery. I think that if inflation is the way the universe formed, then our understanding of existence is far from complete. Someday, we'll all have to admit that it's a Fred Hoyle universe. Getting back to my canoe trip, I think I'll have to swallow my pride and hitch a ride from my alien friend, Magloob Gloob. Thanks for watching. Talk to you soon.